In the late 1950s, a young graduate student who later went on to get a PhD in both physics and mathematics walked into Richard Feynman's office. He showed Feynman his new audacious theory that combined both Einstein's special relativity and quantum mechanics. Frederick Alzofon, since World War II, had worked at Berkeley's atomic synchrotron facility, where he observed and measured a strange effect of how gravity affects subatomic particles. Feynman was used to harebrained ideas being pushed across his desk. But after reading Frederick Alzofon's paper, he said, "There's nothing wrong with your mathematics and there's nothing wrong with your physics. Go away, finalize and publish your paper." By early 1962, Frederick Alzofon published his paper on how gravity might really work. It immediately got the attention of the US Air Force, who recognized Frederick's ideas as the most viable way of building an anti-gravity platform. But Frederick didn't want the control of gravity to just be another small step in producing an ultimate weapon. He wanted the mastery of gravity to be a giant leap for all mankind. So he openly published his theory and included a practical experiment on how gravity can be affected by atomic spin. The Alzofon effect is now regarded as one of the most viable methods of altering gravity. I am honored today to bring you my interview with Frederick's son, David Alzofon, who has continued to carry the flag of his father's work. Ron Evans from BAE Project Greenglow thinks the Alzofon effect is very viable. And today Falcon Space have actually built a machine, an experiment, to demonstrate the Alzofon spin effect on subatomic material. So viewers, does it work? Well, think about this. To traverse the vast distances of interstellar space, an advanced extraterrestrial race would need to master both gravity and the manipulation of time. And David Alzofon thinks there's a clue we can all see on how this advanced technology might work. This clue is often overlooked, but actually hiding in plain sight. Many observations of UFOs see craft with mirrored symmetry. The classic flying saucer shape, the spherical UAP, egg-shaped vehicles, large flying triangles or diamond-shaped craft, all have vertical and horizontal symmetry. I can't wait to share this fascinating interview with David Alzofon, who proposes a sixth observable clue to how UFOs might really work. He says the unique metamaterial structure of the UFO might control space and time. Its symmetrical shape might cut down drag, and all it would take is a tiny force to propel it through time and space. David Alzofon thinks we are on the cusp of understanding and building that technology here today. I agree, humanity needs to conquer gravity, to take our next giant leap into space.
Hey everybody, we have David Alzofon. Hi David, how are you?
Well, Simon.
David is a very famous author and writer, has worked in Silicon Valley and currently is living in California. But he is also the son of Frederick Alzofon. Frederick, his dad, was the man who basically wrote a theory which unifies Einstein's general relativity with quantum mechanics. Now that is a big thing to claim, but Frederick's theory very much focuses on how gravity might really work. So David, tell me about your dad. What era did he live in? Where did he study? And and that will put into context what he actually did.
Certainly, it's an interesting story. His parents immigrated from Odessa in the early part of the 20th century, and he was born in Detroit. Um, Jewish parents and very Jewish upbringing, but he decided he could not believe in religion at an early age, and he chose to believe in science.
Mhm.
And that led him to a technical school in Detroit, and from there to UCLA. Uh,
And
and
this was in the
then,
1940s?
yes, this
Ah,
was,
right.
yeah, right. And he got his master's degree in physics and mathematics from UCLA.
Right.
And then the place where it was happening, the center of the world, was UC Berkeley with the cyclotron. So he went up there to study with Robert Oppenheimer. I'm name dropping, but this is true. And he, David Bohm,
Right.
and eventually with Victor Lenzen, who was a friend of Albert Einstein's,
Right.
and he got his PhD in applied mathematics. He went all the way to the PhD level in particle physics, but he didn't like the department, so he jumped ship after taking his oral exams and passing them. He jumped ship and went to Evans, became a graduate student of Evans. He was the last
Right.
graduate student of Evans.
And just a bit of context. So we've had Einstein, but we've also had quantum mechanics, and we've had Niels Bohr, we've had all of that, which really upset the Einstein apple cart. And the two inner space, the quantum field, the world of the subatomic doesn't correspond to the world of big atoms of the far field universe that we all live in. So your dad must have grown up knowing that there was great respect for Einstein and general relativity and special relativity, but would you say that he thought there was something missing?
He thought Einstein went wrong when he formulated the general theory of relativity because it was a mathematical model of reality, not a model based on physical observation. And he was especially driven by what could be observed in the laboratory. And what you mentioned about Niels Bohr, for example, would be the kind of thing that inspired him. But he couldn't reconcile the quantum mechanics with general relativity. So he simply did away with general relativity, which earned him a lot of enmity among the physicists.
Mm-hmm.
And mind you, my dad was completely a mainstream physicist, and this has always baffled me because
Right.
he's ignored. They can't really dispute his credentials, but they ignored him because he was not on the team. And general relativity was driving research grants and lots of confirmation of the general relativity. It was good at predicting, but maybe it was wrong, and he had an alternative. And he spent his entire life formulating that alternative.
Mm.
And the man was more dedicated to physics than anyone I've ever known or ever seen. And this was included his retirement. In fact, kind of like me, I viewed retirement as freedom to study even more about music. He reviewed it as freedom to study more about physics. He lived in Oregon. He used to go to the Oregon State University Library, and they knew him extremely well because he would read all the latest publications on general relativity and everything they had on the shelves about anything dealing with gravitation and relativity. And
Right.
the result was he came up with his own theory that united quantum electrodynamics with relativity. And
Can I interrupt and focus on. So I would say that reading his works very much through your books, which are on your dad and on the subject, which are really fascinating. There's a link in the description to David's book. What was it that he observed experimentally or in reality about gravity that he thought wasn't properly expressed by general relativity or Albert Einstein?
Well, Einstein made a kind of a deviation from the history uh, of Maxwell's equations and Bohr's observations when he came up with general relativity.
Right.
And my dad set out to put things back on track. That was the purpose of his unified field theory. And of course, as I'm talking, there will be many people out there who don't know that Einstein tried all of his life to come up with a unified field theory, and he failed.
Right.
So this was a big deal, and he wrote to Einstein about it, and he didn't receive a reply because, unfortunately, Einstein passed away before he could reply. So my dad went to talk about it with Feynman, Richard Feynman.
Richard Feynman, yeah. Well, what a great meeting that must have been. That was where was Richard at the time?
Caltech.
Oh, at Caltech, not at Berkeley. And so your dad went to had a meeting with Richard. Richard must have met lots of people, constantly knocking on his door. How did that
Right,
meeting
he had
go?
open office hours. So my dad just went during his open office hours and walked in.
Imagine.
And Feynman was kind of testy with him. He had lots of people come in with harebrained ideas about physics, and he had to put them down, and also, not destroy their egos, but he had to point out flaws in what they did. And that's what he tried to do with my dad. And of course, I only have my dad's report on it, but I believe it after seeing my dad deal with some of proponents of general relativity, that he was able to counter all of Feynman's arguments.
Oh, right.
And afterward, Feynman said, according to my dad again,
Yeah.
that you know more about particle physics than anyone who has walked through into my office before. And I can't bust your theory, but you got to work some things out and publish it. This was in 1956. And then in 1960, he published the first paper on the unified field, or rather, it was actually on the origin of the gravitational force, because he thought what he did that was unusual was that he placed gravity on a par with the other forces of nature by giving it a physical causation. In general relativity, it's a quasi-physical causation. It's an observation of how gravity behaves, and then you build a mathematical model, curved space-time. It's very complex. People make whole careers out of it. But maybe it's wrong because there wasn't a connection to other kinds of observations about physical forces of nature. And his theory was based on, well, he reasoned very simply. I love to repeat his reasoning because it's so elegant.
Go ahead.
He said, okay, we have this force which is present throughout the universe, and it's the same everywhere, regardless of the type of matter that's involved. If there is matter, there is gravitation. So he looked for a common denominator in matter, regardless of what type of matter, regardless of the heat, regardless of any other property of the matter. Simply, what do all large bodies of matter have in common? Elementary particles. So he thought, logically, we want to look for gravitation in elementary particles.
The inner world, the subatomic, right?
And this is where his experience with the cyclotron meshed with his growing theory about gravitation. And what he observed was something that we only know by its effects. We can't observe it directly. It's called virtual processes. And there's a kind of limited view of virtual processes. He expanded it. He said, when you have an elementary particle, let's say a proton, neutron, electron, let's just say an electron.
Okay.
It's a ball of energy. Somehow radiant energy has become wrapped around itself and stuck together. And it shades, okay, it's like a bell curve. You have more energy
Right.
at what we call the particle, and then it shades off to infinity. And on the fringes, what begins as a kind of random chaos of particle creation and annihilation. These are virtual processes. And so he thought, well, you get a whole bunch of matter together, you're going to have a cloud of a blizzard of virtual processes going off into space, surrounding the planet or the asteroid or something big.
Yeah.
But actually, of course, it applies to things that are small, like us. We have our own gravitational field, but we're affected by the Earth's gravitational field. And suddenly, everything that's odd about gravity, for example, you can't build a shield that protects against the gravitational force. You can't use electromagnetism to interfere with it. These are very odd things about gravity. It's a very weak force,
Right.
but on a cosmic scale, it becomes extremely strong. You have things like black holes, which are just suck in everything with the gravitational force. So all of these things were explained when he connected gravitation to elementary particles. As he used to say, microcosm conditions macrocosm.
Yeah.
I've looked for that saying elsewhere, and I think it was his saying, his original saying.
Right.
So what we see out there in the cosmos is a direct result of what's going on in the microcosmos, the elementary particles.
Elementary, right.
And that was his big insight. And then he made it mathematical because, again, he had the background with Evans, and he published it in 1960. And that's the paper that caught the attention of the Air Force because it was the only one in existence at the time. They were all about general relativity, and general relativity doesn't offer any physical handles to interact with gravitation. So it's useless in terms of propulsion. And you see attempts to make it, to cram it into a Procrustean bed of physical interaction, and it doesn't work. So he came up with this theory that it had the potential to become a propulsion system. And that's what they noticed. And they said, well, that'd be great. How soon can you build something that'll fly? He said, that's not the way research works. So anyway, that begins the next chapter.
He had his meeting with the Air Force who were wanting to build the craft about the same year he published his paper. Well, in the early 60s anyway. Yes. It needed experimental work, and certainly experimental work has gone on. I recently talked to Ron Evans and his team from Project Greenglow, who work for BAE, British, a big defense company in Britain, and they cite your father's work as the Air Force did, as the most viable process that can have experimental work carried out from it. It's quite practical in some ways to look at how gravity works and how you could build a gravity modification device. I think, and today we have the company Falcon Space and others probably who again are looking at your dad's work very seriously. That's what I hear. So what happened next?
Okay. He walked out of his discussions with the Air Force colonel.
Yeah.
The Air Force colonel's laughter was echoing in the hallway. The reason he walked out is because the Air Force colonel said, you may not have a classification high enough to work on your own project. Catch 22. And he could see what was coming. They were going to classify his project. The words of the Air Force colonel were higher than the Manhattan Project. He had been around the Manhattan Project. He knew what was going on. in the 40s. And there have been some dramas about that. And it was,
Yeah.
well, it was a desperate race to beat Hitler and Tojo, but it was also the dawn of this paranoid
Yeah.
threat and secrecy era, and he was afraid that they would classify his scientific work and take it out of his hands, and he didn't want that. So he walked out. He also knew that from the way they were talking about it, they're going to make a weapon out of it, and in other words, a bomb delivery system. And he wanted no part of that. He saw it as a way of opening the space frontier. And when I was 7 or 8 years old, that's what he told me. So he was very consistent about that throughout his entire life.
Mm.
The purpose of building a gravity control device is to make it easy to get into outer space. That was the whole idea, is to make it easy to explore the interplanetary regions and Mars and, well, at the time, Venus. But Venus is a pretty hot place, so
Yeah.
that's off the table. But the moon and Mars and then the outer planets would all open up because you could get between the planets very quickly without resistance from inertia. You could just power your ship across these vast spaces cheaply, easily, with large payloads. And we can't do that right now. We have to build these rockets that are as high as 30-story buildings, and then they burn up all their fuel just getting off the Earth, and then there's very little fuel left over to maneuver once they're out there. All of that would go away as a problem. And in addition, I have to say this, the dream of having personal aviation vehicles would be realized too. You could have a flying saucer in your backyard. Why? Because you don't need a runway. You just go whoop, up, straight up, and then take off at whatever speed you want. Mach 2 would be easily reachable. And that was his dream, to get to transform the commercial outlook of the Earth via gravity control, and to explore space, and not for the purpose of the military.
How noble, and I completely support that. That's fantastic. And you carried on that dream that your father very much championed. Great respect, David. Talk to me just about a bit basic physics here. When we talk about gravity, we do need to also talk about time. So a gravity device isn't just anti-gravity, a lift device. It is also going to be in its own relativistic time. Would you agree with that? And that's
Yes,
very
I would.
important for crossing vast distances, because you would never, how would an organism live, say, 100,000 light years? If light speed is the ultimate speed, it would still take 100,000 light years to go that distance. But if you could modify both gravity and time, so is gravity and time, are they linked?
Yes.
Right.
But they're linked by the way we observe anything, which is via the medium of electromagnetic radiation. And that leads to some changes in our perception of objects moving at close to the speed of light. And you get time distortion and that kind of thing. I have to admit, I'm not as well versed in that matter as the gravitational gravity control. But I do know this, that Fred didn't disagree with anything in special relativity. So whatever conclusions were drawn about time and and at the edges of the limits of time, that he agreed with Einstein on that.
Seems to me that occupants of a gravity modification craft, and we should talk about the actual physicality of the craft, would be in their own relative time. And okay, us outside it would see them maybe disappear or reappear, or traveling at incredible speeds that would be unimaginable. But for the occupants inside, if us in the future or another civilization did manage to modify gravity and time, that would be necessary to overcome the vast distances and speeds, and also the g-forces. You know, a lot of the things that we are seeing, the UFOs that we're seeing, seem to have incredible accelerations, to the point where you would be thrown to the side of the craft and pulverized. If you know, you can't take 30, 50, 100 G, but if you were inside a craft that was in a bubble of its own relativistic gravity and time, maybe you wouldn't have those effects inside the craft. Let's jump straight into, from that fantastic, amazing background, and many people working on your dad's theories today. Actually, David, we need, as a human race, to break through this barrier and become a race of people who can master gravity and time. So, if an extraterrestrial, if an advanced civilization, or maybe us in the future, because it could be time traveling us, did build a craft, what would it look like? And are we seeing craft? Are we observing UFOs that have any hints that they are gravity modifications? And what would their shape be? Is there a clue there?
Oh, absolutely. As the observations about UFOs and UAPs multiply, none of them have contradicted the predictions of my father's theory. In fact, they constitute an indirect proof of the theory.
Right.
And we could get into that. I mean, I'd have to do a university course to cover all of them, but
Right.
I think you mentioned the configuration of a UFO hull, the form of a flying saucer, which was ridiculed throughout the 1950s.
Yeah.
As ridiculous. No wings, no rockets. What are you talking about? You're hallucinating. And it zips away at instant accelerations. The occupants would be killed. No, they wouldn't. No, and that is part of the theory. And so let me run down a story about a flying saucer.
Please.
I was visiting my dad in Oregon, and I just wandered up to the stairs to his study. And as soon as I walked through the door, he said, I want to show you something. You know, he was kind of like, he did a lot of unexpected things, and this was one of them. So he said, get that book off the shelf. And so I pulled a book off the shelf. It was a really old book with old-fashioned hardcover binding. And I looked inside of it, and it was all mathematics. He said, that's a book about radar, and I picked it up at a library sale. It's amazing what you can get at library sales. And I said, oh, okay, so what? And he said, well, turn to page 720 and take a look at what you see there and tell me what it makes you think of. Well, it was an ideal radar antenna. And I have a model of a radar antenna here. I have these bigger saucers, but this is a radar antenna. A parabola. And
it's a saucer. It's a dish. Yeah.
And if you take two radar antennas and you put them together,
right. Yeah.
You get this. And this is a flying saucer. So the purpose of the saucer shape is to distribute the orientation of elementary particles from a center post from the top to the extreme sides, the rim.
Right.
And that completely envelops the craft in the field that you want, that frees it from gravitation and inertia. And the reason I keep saying gravitation and inertia is because it's been known for a long time that they're proportional to each other, directly proportional to each other. In fact, Einstein called it the equivalency principle. And this has been a mystery since he enunciated it. But it is explained in my father's theory. He attributes both forces to the same phenomena, this Zwitterbewegung, the agitation of virtual processes. And so if you calm the field around the ship, you free yourself not only from gravitation, but inertia. And this is the ideal form
And that's the
for
form.
the field to be projected to the hull of a craft, not a airplane which relies on wings to
Oh, right.
stabilize and stay up there, or a rocket, which is essentially a tube with a controlled explosion on one end.
Yeah, Newtonian, yeah, propulsion, right.
A
But
Newtonian
the
rocket.
so we've seen flying saucers, we've seen UFOs for centuries, and there does seem to be a general type that people, humans, have seen all over the centuries. Which they're not necessarily double saucers, but they're often round or egg-shaped. I think if I had to sum it up, what would you say if I used the word symmetrical? Do you think
I,
that word is important?
Axial symmetry. That's the common characteristic of all of these shapes. So you have, for example, a birthday cake shape, and you have a triangle, usually a equilateral triangle, which has equidistant corners from the center. And all of these shapes have axial symmetry, which is the best way to conduct the effect to the hull of the craft. And it's really simple once you look at it this way. And the fact that these things are flying around out there
Yep.
is in direct confirmation of my dad's theory of their propulsion mechanism, which he wrote about extensively, by the way, and which I tried to cover completely in both of these books.
Yeah, read them. They're good. Uh, it seems perfectly reasonable. And also, the defense contractors and the military and governments at present are very much observing what they're calling the five observables of what they are seeing, because it's probably less likely that they've got one, but they definitely see them all the time. And there's physics and science and engineering to be gleaned by observing their shape and movement and style and what they do. So yeah, symmetry. We see it all the time. I mean, we see symmetry also even in not solid forms, in plasma or in things like that. The symmetry seems so important.
Yeah, my dad used to lecture me. He gave me physics lectures all the time, and one of them was about soap bubbles and how the soap bubble was the most efficient way for a film to form around a bubble of gas. So we take it for granted. We take symmetry for granted because we see it all the time in nature. These vehicles, like I just put together out of two saucer dishes,
Yeah.
reflect the same thing. The most efficient way to form a bubble is a sphere. We see spheres that are also UAPs, and we see these saucers because they're a more aerodynamic shape, so they can travel through the atmosphere quite easily. But they're the same thing. They're symmetrical.
So there might be a craft which could be, as you said, wedding cake shaped but symmetrical, or diamond shaped, which is symmetrical, which is perfect for, say, a non-atmospheric interstellar, but maybe a probe or a craft that needs to go and descend into a planet, maybe Earth's atmosphere or other planets' atmospheres, might need to have the dynamic shape of something more aerodynamic as well as the symmetry.
Yeah, well, when we look at alien civilizations, plural, that seem to be visiting Earth, I imagine I don't know anything about them. I don't have any telephone line to the aliens, but it's pretty clear that there are different levels of technology represented in the craft that they bring here. And the basic physics of gravitation seems to be the bedrock for building all kinds of different craft. So we see saucers, and we see orbs, and we see gigantic triangles, and
Yeah.
all kinds of things out there. I think they simply represent different levels of evolution of the same technology. But the physical principles are the same. They're not going to
Well,
use an aerodynamic craft. It is inefficient, and we're pretty good at it, and we've kind of hit the limit with it.
yeah, we're very good.
In the future, I expect to see more saucers.
I completely agree. So possibly a more advanced civilization has mastered gravity modification and found that the symmetry shape is ideal. I just think that's fascinating, and I think we should, as I think humans now in 2025, we're right on the cusp of a giant leap forward into beginning to understand through experimentation and theories, like your dad's, how we as humans will move off Earth and into interstellar space. And I think
I
we need.
completely agree.
Do you
I
think
think,
we're going to do that?
what's that?
Do you think that that's in our reasonably near future? Do you think we're heading in the right direction?
I think it's very low-hanging fruit at this time. I think all we need to do is set up a really energetic program to research my dad's propulsion system
Yeah.
in detail, because in spite of the fact that it's fairly simple to describe, and I haven't really described it yet, but it is simple.
Right.
Despite that, you need a lot, there's a lot of details that have to be worked out in setting up this propulsion system, and a lot of experimentation. It's very expensive, but never been done. There was an experiment in 1994 that seemed to, it was, my dad described it as promising,
Right.
but it was only one experiment. It was done very cheaply, and the equipment had to be returned to the owners after it was done. So it
Right.
wasn't conclusive, but it was promising. I will
Right.
say that. And now we have Mark working on the East Coast on a recreation of 1994. And what has he found? Well, there's a lot of problems in getting
Yeah.
the orientation to permeate the sample, which is when you expect to see gravity diminish. And I think most of his problems have to do with getting the sample to uh, become fully oriented so that they can keep pulsing it with orientation. And it's a kind of an on-off cycle. And during the on cycle, gravity increases. And during the off cycle, when the particles are recovering their random motion, during that cycle, gravity diminishes. It's a process that is used for cryogenic freezing. Of course, we're doing it with gravity here, not with molecules, not with kinetic energy, but with
Right.
gravitational energy. We consider them equivalent,
Yeah.
analogs of each other,
Right.
analogous. But if we, during the on cycle, when we're driving the electrons in the atoms of the hull,
Yeah.
gravity will increase momentarily. And I'm coming to an interesting point, by the way, about UFOs. Um,
Yeah.
then when we switch it off, the disorganization of the virtual processes is coming from the gravitational field.
Right.
And so the mean energy of the field is going down.
Right.
Each time it has to do this, and it does it thousands of times per second,
Yeah.
it's losing energy, and it's a pumping process.
Yes.
And
Yeah.
yes, your finger there is describing a pathway, a flight path observed in UFOs, this undulating flight path.
Oh.
And it is explained by during the on cycle, it's getting heavier, so it goes down a little bit. And then during the off cycle, it is getting lighter, and it's going up because it's more buoyant. It's as simple as that. So you get a skipping stone motion as it flies through the atmosphere.
Which has been observed. Yeah.
Yes, the very first observation of a UFO modern period was Kenneth Randall or Kenneth
Kenneth Arnold at Mount
Arnold, yeah,
Rainier. Right. Right.
at Mount Rainier. Yeah, and he said
Right.
they were flying like skipping stones, and this led to the term flying saucers.
Yeah. Sure.
But that wasn't what he observed. What he observed was a kind of semicircular form. Um, a spaceship of some kind.
Again, symmetry, that's what he described, and the saucer or the symmetrical shape was mentioned. Oh, yeah, that's really fascinating. It seems maybe that we need that what Mark and Falcon Sprace building up on from your father's work is also looking at material science as well. I mean, it seems to work with specific types of materials better than others, and that needs more work.
Yes, this is another thing predicted by my dad's theory. And here, let's go back into history. In 1960, he had no idea of how these things were the propulsion system they were using. He believed they were there because of Project Blue Book. There were 750 cases that were unexplained, and he'd heard rumors inside of the community.
Right.
And sorry about that. He'd heard rumors, so he believed they were there, and he was very curious about how they might be propelled. Well, I ran across a book in 1976 by a nuclear engineer by the name of Jim McCampbell, and it was called Ufology. And the book itself is online right now. You can look it up and read it. And there's a chapter in there about microwave propulsion. And it had the story of a UFO that was spotted over the Gulf of Mexico by a electronic countermeasures training mission.
Yeah.
And so they had an antenna aboard, and they could take readings on what this UFO was emitting while it was flying. And what they observed was pulsating microwave radiation. And so I sent him the book, and it took him probably about a month to reverse engineer the propulsion system once he had that data. And then he put a patent on it, and that was in 1981. And then he flew to Boulder, Colorado for the AIAA Joint Propulsion Conference, 17th Joint Propulsion Conference. You know, the copy of the paper he delivered there on the bookshelf behind me.
Yeah.
And he did that because his experience with the Air Force convinced him they were going to clap it under classification immediately. So he didn't want it classified. So he read this paper in public to put it on the public record.
At an open science conference. Yeah, very good. Right.
Yeah. Well, unfortunately, his patent was not granted. There was no good explanation why. I think it collided with a secret level of patent that he was never privileged to see. Anyway, he didn't get it. And as a result, he had given away the whole thing. And it's prior art now. You could build an anti-gravity device, let's call it a gravity control device, using what you found in that paper. I don't know whether you can patent it or not, but if you put it inside a vehicle, it's definitely patentable. So you have to, you got to get it to a higher level than it currently exists. It's more, he wondered if he could even patent it in 1981 because it was a physical process. It wasn't an invention, so to speak.
Right. It was a description of a better description of the law of physics, which isn't patentable, but yeah, a craft would be. Oh, fantastic! And what I'm hearing is that paper probably spurred a lot of people above and beyond secrecy to work on it.
It did. In fact, I heard a rumor from somebody who was in the know, evidently, that his paper was immediately given to 17 mathematicians who worked for the CIA to verify the mathematics, and their conclusion was that everything in the paper was correct. And the person that I talked to told me not to tell my dad, and that was probably good advice. But I did tell him about 2 months before he died. He was 93 when he died, and he was furious. He was furious that he wasn't given the right to to look at the alien vehicles that are allegedly at Area 51, S4, and so forth. He was not asked to reverse engineer those, but I think that probably goes back to you probably can't get a clearance high enough to work on your own theory. That kind of bureaucratic thinking is why he wasn't called in to reverse engineer these vehicles.
How
He was
short-sighted
desperate.
of whoever has them, the Air Force or the Navy or the Department of Energy, whoever's in control of them, because your dad would have understood the function of the shape and the drive mechanism, and could have said, "Oh, look, that bit works with that bit." I mean, rather than having people who didn't understand your dad's theory, scratching their head, it might have suddenly all come together. So yeah, there was a definite missed opportunity. That's a shame.
It makes no sense to me because when my dad was in aerospace, which his whole career was in aerospace, 30 years,
Oh,
he came up with solutions one after the other to problems that nobody else could solve. For example, infrared non-destructive testing for rocket motors.
yeah,
That, I mean, that's not as glamorous as gravity control, of course,
right.
but it was a problem they couldn't solve. And so he solved it. And he
Right.
was called in to consult on why these rockets were blinded on their takeoff missiles and rockets. They had optical sensors on the outside, and they were becoming blinded on the way up through the atmosphere. And they had an entire bureaucracy devoted to solving this problem.
I bet.
In effect, they couldn't do it. So he was brought in. There was an Air Force general this time who said, you're going to follow whatever this guy says. You give him everything that he wants. And they fought him. The bureaucracy fought him, but he did solve it.
Right.
And after he solved it, he said he had to move to Texas because Lockheed was really pissed at him because he had wiped out a contract, a
Whole
huge
contract.
contract for the
It's
study.
solved. It's solved. We don't have to work on it. Right.
A bunch of people were jobless because he solved it. This is just incomprehensible if you're not in the aerospace industry or government,
Right.
yeah.
Right. Right. So did your dad ever did he continue to be interested in UFOs and ufology when you, of course, showed him the book with the ELINT plane encounter over Texas and the Gulf of Mexico? That must have been amazing. Was that his first interest in that field, or you said he knew a bit about Project Blue Book, and did he continue to be interested?
Oh, it was the first time he had hard data on their propulsion system because
Oh
that's
yeah,
what's in that book.
right.
Before that, it was just a mystery how they managed to do these instantaneous accelerations without the killing the occupants and that kind of thing. He knew that he had an idea, a vague inchoate idea of how they were doing these miracles of physics, but
Yeah.
he couldn't connect it to the physics that he understood until he saw McCampbell's book. We even saw. I want to in this book here. I keep plugging my books. Top 10 UFO riddles,
Hold it up.
uh,
Top
which is
10.
on.
Yeah.
It's on Amazon. The reason I bring it up is because I did tell the story of a number of sightings that occurred when I used to go outside and look up at the sky a lot. I don't anymore, but
Oh,
I just that I'm just inside playing guitar or something like that. That's the only reason. But when I was a kid, I was camping on the beach in Big Sur and
sure.
surfing and that kind of thing. And on a camping trip to Mount Lassen, the whole family was camping by the side of the American River, and we were looking up at the sky. And this was in the 1960s.
Yeah.
And there weren't very many satellites up there at the time. My dad said, well, let's see if we could see a satellite. So we found one. And it wasn't, he said, it's funny, it's not going the right direction. Because he knew all the satellites that were up at the time.
Yeah.
And at just about the time he said that, this satellite, which had been moving slowly across the heavens, like a star that was in motion,
Yeah.
it stopped mid-heaven, completely stopped. And we were just, open mouthed at that and laughing too. And he said, well, it's not supposed to do that. And then at that point, it took off doing a zigzag path that no conventional vehicle could possibly do,
Fantastic.
let alone at that altitude. So we actually saw a UFO at that point.
Yeah, definitely nothing. It's not a man-made craft of any description. Oh, that's fantastic! What a great sighting. Let me just nail something again for viewers and for me, because I'm a journalist rather than a physicist. It's okay. So we've got a theory of this, how the near-field subatomic redefinition of physics might be a better definition of gravity, but what I don't understand is what's the connection between the sighting over the Gulf of Mexico with that frequency. How did that explain how they were pushed? So first of all, you need to modify gravity or mask it, and then you need something to propulsion. Is that am I roughly right? Do you need both?
You need separate technologies for both. Once you cancel gravity, you don't get a propulsion system. What you get is a vehicle that's easy to push around using anything.
Anything, a little force.
Very small force. In fact, he said that if they were using the Earth's magnetic field, they would fly like a bat out of hell.
Right.
All they'd have to do is set up magnets in the hull, and then propel themselves against the magnetic field of the Earth, and they would go many times the speed of sound. That's one way. They've also, there was the case of Lonnie Zamora in New Mexico. This is a very famous UFO case.
Yep.
You might know it. Have you ever heard?
Yeah. Sure.
Obviously, that ship, which parked itself in the desert,
right,
while being watched by a New Mexico Highway Patrol officer by the name of Lonnie Zamora, a very upstanding member of his community and church, and completely believable.
And it was symmetrical. It was eggy shaped. Yeah.
Well, it was shaped, I gather it was shaped like many of these UAPs that are seen. And it was also a similar color. But when it took off, it went up, and then it was using a very small rocket underneath it to propel itself into the air.
Oh, wow.
And then it hovered and moved sideways. The rocket shut off and it moved sideways. Well, this is a clue to how it was being propelled. Right. The rocket was just to get up to off the ground, so it couldn't be interfered with by people on the ground like Lonnie Zamora. And then the sideways propulsion was probably when the magnetic system took over.
Right.
Yeah, so they had twin propulsion systems, but the gravity effect is completely independent. It is not a propulsion system. It doesn't actually move you through the air. Now, I have heard of some other people that are attempting to use it that way, or they think that it can be used that way. The physics is beyond me. It might be possible. I think this whole theory of this propulsion system needs to be explored in detail. Right. And right now it's an infant science, but it is possible because you have a theory to invent new things that use the theory in new ways. You can't do that with general relativity because, once again, there's no levers to grab hold of physical reality in general relativity. It's very descriptive about the behavior of gravitation, but it doesn't provide a connection to the other features of physical reality.
Yeah, I was talking to Ron Evans about that, and we were saying that really in the classical Einstein space-time mass and gravity triangle, the only thing that affects space-time and hence gravity is massive amounts of mass, like a star or a black hole or anything really, but more the bigger the better. And you're not going to have that in a box. You're not going to have condensed matter to affect gravity, and that would only distort gravity in a well to make gravity more positive. The idea of making gravity into a hill with it doesn't work. That wasn't the way. That isn't the way to approach gravity modification for a craft.
I think my dad would say you have a very healthy instinct in that you're reaching for visual metaphors
Right.
for the force of gravity. And he believed in the power of visual metaphors for uncovering the way things work. And his theory is definitely very visual.
Wish I'd met him. Oh, but it's an honor to meet you, David. It really is. And I certainly recommend your book. Go and get it. I got it from Amazon, so it's available right now. And it publishes your dad's paper, which tells you how to build one.
That's right.
If you've got the funding, buy the book, go out and build one. I think we do need a Manhattan Project V2 right now to actually get going. Humanity needs to take that next giant step into gravity, into understanding gravity, and then gravity modification and craft.
There are pools of money sitting out there that are just gathering dust in banks that could be applied to this. It's it's an easy lift for a science project. It's not a multi-billion-dollar project to measure gravity waves. It is a very simple thing you could build in a small laboratory. Mark Sokol is doing it.
Yeah.
There's one more thing I want to say about this book. This book contains my father's last paper, which he was struggling to get published, and finally he put it on Vixra in order to memorialize it. So I copied it from Vixra and I edited it using his papers that I got from his study after he passed away. And the version of that paper in here, which explains dark energy and the cosmological perspective that he had, is in here. It's way beyond my ability to understand, but if you're a physicist, enjoy reading it.
Sure. But he was also an experimentalist. That's what it comes across from reading your book, that he enjoyed finding experimental proof. I mean, obviously, his background in working at the synchrotron, I mean, that was an amazing piece of physics that was turned into a device. I mean, how incredible to actually be around something so big and so fundamental. Was that right? Did your dad enjoy, did he tinker? Did he build stuff himself? He obviously worked in aerospace.
Yeah, he did. Well, going back to infrared, he devised an experiment that would measure radiation coming off the surface of a rocket motor.
Right.
And the problem was for other scientists that they couldn't organize the data they were getting so that they could get a read on flaws in the rocket motor at a depth beyond the surface. And he was able to do that.
Right,
experimentally. So that's just one. There are others, but gravity was the big one.
But did you grow up surrounded by a laboratory, oscilloscopes and steam engines and a lathe and bits of bent metal and antennas in your house?
Oh, he used to take me down to Zach's Electronics in Palo Alto, which was before the semiconductor revolution, and he was building things that had to do with radios and TVs.
Right.
But most of my memories surround him sitting at a Royal Portable typewriter, tapping away on scientific papers and turning the carriage a half turn so that he could put superscript
paper. I love it. Yes, I have some. Oh, I've gone out of focus. Excuse me, camera. There you go. Hi. Um, A friend who works in Silicon Valley, who's old enough to know, said, Simon, it wasn't Silicon Valley. Silicon Valley is its new name. It was Microwave Valley, very much after when Robert Watson Watt first came up with his idea of radio direction finding, which eventually got absorbed and turned into the word radar by you wonderful Americans. And microwaves were used in all kinds of different technology. The whole of the what became computer Silicon Valley started off as Microwave Valley. All these companies, Hewlett Packard and Sun and things, were all making microwave kit. Have you heard that story?
Well, I didn't have to hear a story. I could see it when we used to drive down Bayshore Freeway. The the buildings along the side had the word microwave on them frequently. So yeah, that was going on. It was the semiconductor that changed everything because then that allowed
But later
computers.
on, it started off very much as a small defense contractors working in the microwave technology. Yeah,
So yeah, microwaves were a big deal in Silicon Valley, and I'm sure they still are. Um,
yeah.
in communications, among other things, and in the future, gravity control.
Well, we need Gravity Valley. That's what we really need. We need to move humanity on um, to get away from fossil fuels and get away from burning stuff generally, especially for rockets. I mean, taking a rocket with a propellant is never going to get us that far. It's crazy.
May
I
I say,
hope
I'd
that's
like to
going to
say a
change.
word to the fossil fuel companies if they happen to be listening. There's
I don't care.
there's an end to fossil fuel. That's it's simply a physical limit. Eventually, we're going to run out. But
Yeah.
they don't seem to care. They're willing to burn all the fossil fuel there is. What they might do is think about setting up a gravity control wing to one of their research centers, because essentially you could move your oil search out into space, except you'd be searching for metals and space mining and that kind of thing, and you would make more money. I mean, this is what they're worried about. They're worried about declining profits. They could actually boost profits by studying gravity control. It's not their enemy, it's their savior.
It's
There
the
was a
savior.
whale oil industry, as we all know, a
Oh,
whale
that
oil.
moved. Right, right, right.
Yeah, it moved over to Pennsylvania oil. So
Yeah, I've got
there's
a good friend who is very involved in environmental studies, and he makes a very positive point. He says big fossil fuel oil companies are staffed by some of the most amazingly good engineers, and what and they need to face, as you've just said, they need to face the facts and actually become heroes, and actually not drill the last drop, but actually move into really putting their research and their science and all the good people that they have on staff to look at alternatives and actually save the planet. Because I mean, fossil fuels is going to run out. Babies, burn your last drop. To this day, we have an electric car and it's not suitable for everybody. Heavy machinery, large calorific, enormous engines need the calories of fossil fuels. I accept that, but we need to wean ourselves off it. The mom taking her kids to school doesn't need to drive a Ford burning diesel or gasoline. Let the man delivering the last mile Amazon parcel, a couple of miles to your house, can drive an electric van. I mean, it makes perfect sense. And then space exploration. We need it because we need to conquer those times and those distances.
a space mining company is going to have a better long-term profit outlook than a oil company at this time.
There you go.
But we can't do it because we're stuck with rockets. We got to get off of rockets and go
Right.
to gravity control as a way to get out there and get to the asteroids and pull the metal out and set up factories out there. We don't have to pollute the Earth with factories. We can put the factories in space, orbiting. What's that called? The L orbital, where they're
The
balanced.
Lagrange points, which is that what
Lagrange.
you're meaning? The ones that are very fixed, like geostationary, and yeah, they're very special places. Like we use them for special space missions. So
So
you're going into
so
material science. Do you think that we could get, even if we ever find anything that's crashed, which comes from a future technology or an extraterrestrial technology, would be another clue, because we could analyze the materials that they used.
well,
Have
that
you?
would give away the whole game.
Ah,
Yeah, as I understand it, there have been crashes, and they were very puzzled at what they were looking at, because the circuitry was integrated into the hull, so the ship was empty inside, and they couldn't figure this out. So the result was semiconductors. They gave the problem to Stanford University, among other places,
oh,
and they were able to reverse engineer this circuitry embedded in the metal. Now, I'm just repeating rumors. I
right.
wasn't there. I don't know. It's possible. So I would expect. Oh, here's another thing. Mark has talked about having a sample of the
Yes.
Roswell crash
Hmm.
saucer. And what he's found, just like other researchers who've looked at it, is very, very thin layers of two different kinds of metal, or maybe three,
Yeah.
aluminum, and I can tell you why they're using aluminum,
Yeah.
and bismuth. And they're very close together. And Mark has a theory about why they're doing this, why
Right.
they're using a kind of pancake sandwich of metals. But the reason they're using aluminum is because the nuclear orientation decay time is longer with aluminum than it is with other metals. And so you're going to have a longer cycle, more preservation of the effect that's lowering the gravitational force around the vehicle
Right.
in an aluminum hull. And it happens to be a great construction material
It's
as
brilliant.
well.
Yeah. Certainly
Abundant too. It's everywhere.
abundant. Yeah, it certainly was good for my Cessna. It was great. It's an excellent aviation material. Oh, well, we live in interesting times. David, we've scratched the surface, because we are about to embark as humanity on this quest. There are people working on it. It needs to speed up. We need government backing. We need international research to do this. And I can't wait for the day that it becomes the Alzofon effect.
I hope to see it in my lifetime, and I still hope to see it in within my lifetime. The
Yeah.
fact that people are interested in it indicates that it will happen fairly
Mm,
soon. And when it happens, everything changes overnight.
does.
You will, yeah, the space frontier will be thrown wide open. Star Trek will become more of a reality than a science fiction story.
Mm,
Faster than light travel is also possible,
mm.
because if you have a vehicle that doesn't have any mass,
Yeah,
well, you can transcend the speed of light quite easily.
sure. It's linked, that faster than light travel relativistic to the craft. Yeah, no, it must happen. Just look at the distances. If creatures, aliens have visited here, they need to have faster than light travel, and suddenly we've got a mechanism. If only we can make it work. I really do hope it happens in our lifetime. I think it will happen in our kids' lifetime. So, David, thank you very much for this fascinating chat. So many more questions. Please dig into the what viewers ask in the description under this video. Feel free to answer anybody's questions. People will want basic stuff answered, and you'll get a few who will ask you very detailed questions. I will forward them to you or just dig in. So thank you very much for today. It's fascinating, and I will continue to speak to you.
I really appreciate the opportunity to speak about this, Simon, because it's always on my mind, but I don't often get to speak to a wide viewing audience about it. It's definitely the future.
Yeah, my audience is international, so a lot of people mainly in Europe. So I think people who haven't heard of your father's work and should check your books and what you've said and dig into it, because it's the future of humanity. Thank you very much for today.
Okay, Simon, thank you very much, and let's do it again.
Definitely.